How do you measure high voltage?
Of course, we can probe the voltage.
Check your setup before committing to something.
The simplest way is to divide the voltage down below what your measurement device can handle. A resistor divider is the way to go. If we can measure the... Oh, damn it. Oh no. Only consume power below their power rating. These 100K, 1K resistors should be good though. There you go. With these values, they remain cool. It is always advised not to touch live high voltage. Same divider trick can be used to measure very high voltages like on my Van de Graaff generator. And 0 volts, it's impossible. I can use my man-made driver which can maintain a much more powerful output. So I'm using a 10 mega ohm and a 10 kilo ohm resistor to divide the voltage by almost 1,000. We turn it on and so I have a 2 giga ohm resistor here that I connected to a 2 mega ohm resistor for an almost 1,000 to 1 division ratio. So we just turn it on. Let's reduce the supply voltage. How about now? How about now? Okay, so we are measuring above 9,000 volts.
How do you measure high voltage?
Okay, so you guys have probably seen him before. I mean, he shocks, but I don't think he's working with that high of voltage. Here's what happens when you work with real world voltage. If you find people getting injured to be difficult to watch, just fast forward. So there's an example of working on live equipment but not having the proper protection. And then finally, this is a video of an arc flash. He's feeding line into a cabinet while everything's still live. And unfortunately, they shorted across 2 poles, and that caused an arc flash, a pretty serious one. So, didn't have to see any gore there. There are a lot of videos out there and pictures of what happens when people are unsafe with electricity, and it's not pretty. So this is the intro video. This is Dr. Lusheen for lecture 15, which is actually a combination of 2 lectures. So I'm going to cover both electrical safety and arc flash in this summary, and then you're going to have 2 lectures to watch and then some additional things. They're interrelated, but I at this point they're covered a little bit separately. So in this particular lecture 15, we're covering subpart S, which is electrical. I had to actually piece together this set of standards because there's so many reserved, but this is basically the electrical standard. Outside of OSHA, there's NFPA 70, which is the National Electrical Code, and 70E, which is the standard for electrical safety in the workplace. 70 would be more for the installation. 70E would be how to approach things when they're still live. Note that these are federal standards. You should also check with your state and local electrical codes. It's difficult to find actual information on injury data relating to electrical safety and arc flash, but NFPA did do a report, and it shows here, the number of fatalities caused by exposure to electrical. We're right around between, 120 and 160 over the last 10 years. The number of non-fatal, which this would be considered shock, there's about, anywhere from 2,000 to 2,400, except 17 had a big jump. So there are fewer injuries and deaths due to exposure to electricity or arc flash, but it's still really scary because essentially, these things, it's like the people are being cooked, almost being burned from the inside when you're exposed to electricity. So I did an accident search on OSHA for electrocuted, and so there are cases here in which people died. You can look these up. I don't want to go over these specifically, just want to kind of show you that there's a series of them. And then if you do by electrical arc, there are other things as well. There are more electrocution than there are arc flash. So the type of burns when electricity flows through the body, and that's what it typically does, it's cooking from the inside out. So you can actually have third-degree burns on the inside in your organs, and not necessarily damage to the exterior that you see, though you'll have an exit wound. So it's scary. It's really cooking from the inside. This one talks a little bit about arc flashes. Arc flashes you would see from the outside. Those would definitely be third-degree burns, but there's other things too. It basically explodes. There's a what do they call it? A sound wave or a percussion wave, which actually will rupture your eardrums. It can cause nerve damage. It blasts molten metal, and it can get into your lungs and burn it. It can burn your eyes. It can do nerve damage. It can kill you. So arc flashes are really scary. You saw in that video how it exploded, and it's just flames and smoke and everything. The other side is that if you don't have proper installation or respect or use of electricity, it can cause fires. I mean, there's not a... It's not the primary cause, but you can see here that it does occur. It can occur from anything from, overdrawing amperage through a circuit to damage line and causing an arc or a spark, or using external equipment from the circuit, actual design circuit. All these things can, but it's tend to be an overdrawn or an unprotected live line. Electrical standards do not fall into the top 10. Here I searched everything, and I'm just going to cover the ones that had more than 100 inspections. So the first one is 1910-303. This is just general electrical, and you can see here, a little over 1,000 inspections, 1,200 citations, about 3.5 million in penalties. For wiring methods, components, and equipment for general use, 1,000 citations, 750 inspections, 2.3 mil in penalty. Selection and use of work practices for electrical work, over 100 inspections, 130 plus citations, and $630,000 in penalties. And then you can see here as well, this is for use of equipment. This is the homepage for the electrical safety and health topics. I have a link in Canvas for this, and there's a lot of great information here. Under the construction e-tool, so this would be for construction, not general industry, but still a lot of this stuff is also relevant. You'll see here you want to avoid contact with power lines. We saw the video where they're working on a live power line. Not having a proper ground or a ground fault protection. Path to grounding may be missing or discontinued. Equipment not used in a prescribed manner, or improper use of extension or flexible cords. That's really, which we call temporary electrical. That's really a summation of the major issues. But then there's a lot of other things here as well. Over here, common electrical hazards, it's talking about overhead lines. You shouldn't be within, 10, 15 feet ever. An electrical line, if you have to work on your house for the one that feeds in, you should actually call the electrical company and have somebody come out and cover it. So you can do your work without incidental contact. Whenever you're moving around overhead lines, you got to be careful. Because if your truck or your boom or your forks, if you got like a lift device, it makes contact with it, you can energize your vehicle. In which case now electricity is flowing to the ground, and you now electrify the ground, and you can get shocked just by jumping out of the vehicle. Incidental contact. You shouldn't be working with live. You should be working on or near exposed live electrical equipment. Only experts can do that, and then they have to follow NFPA 70E. So basically, electrical should be both labeled and enclosed, and really only access to those that are trained and certified to do so. And I have it over here. If you install everything to code by a certified electrician, it should function as prescribed. It should be enclosed and labeled. Only people with the knowledge of how to properly work with it should have access to it. So things should be locked away and labeled. If you're going to work on it, they're going to work on it, it should be de-energized. Use lockout tagout, which we'll cover in a future lecture. And then you also have to verify that energy has been isolated. If you're not able to, then you have to use NFPA 70E, which is protected PPE and procedures to mitigate working on live equipment. You should do periodic visual assessments for the integrity of those systems so that they're working properly. And then also you should limit the use of extension cords or temporary wiring. Here's an example of the application of NFPA 70E. That there are zones based on the power of the load center, and every electrical box should have this warning on it for arc flash and shock hazard and appropriate PPE. And things tend to be measured in kilocalories or calories per centimeter squared. And yeah, other resources that I can recommend to you would be contact the experts. Faith Technologies, Peeper Power, I know safety people in both of those companies, so I highly trust them. I've also heard of Westfall. I think they're good too. Bring in the experts. Because when I've done some of my consulting work, I've made recommendations. You guys got to bring in experts to take care of this. It needs to be wired properly. I myself kind of, consider myself sort of a novice electrician. I could probably sit for the state licensing exam or certification exam. I do residential wiring. I do that because I worked at a Home Depot for a time, and electrical department, I learned how to do certain things, learned the code, and I still read the code. So I've done some electrical work on my own, but I wouldn't recommend it. I understand the basic principles of the design, how to calculate voltage and current and things like that. So anyway, don't recommend you do any of that work. I think I say in one of my videos this week that I was going to actually demonstrate, but due to my lack of actual state licensure, due to my lack of actual safety precautions in the video, I actually scrubbed that video I had made. So watch the 2 lecture videos, check out the links in the PDF. I've got some additional videos for you to watch, though I covered most of them here. The objective is to gain a basic appreciation for the hazards associated with working with electricity, which nobody should accept if you're licensed. And you definitely have to be donning NFPA 70E, PPE, and practices when you're working on live equipment to avoid an arc flash, because it's a scary thing. I was exposed to a very minor arc flash when I was doing some wiring. It scared the hell out of me, but I got very lucky. It was actually in the opposite direction of where I was standing. So that's what we got. So enjoy the 2 videos and check out the additional content that I've put on here. All the stuff is meant to inform. You should check out the electrical. I also provided this handout, Controlling Electrical Hazards. And then also under the Safety and Health, OSHA Field Safety and Health Manual, they talk about what a compliance officer would look for and do for electrical and arc flash type inspections. So that's all for you. Thanks a lot. Bye.